Okay, we've done something like arc length before. We're going to do it again. Before, though, we did arc length in terms of x. This one is going to be in terms of t, again with x and y being our dependent variables. So the question is find the arc length of the given curve if you have a parametric equation where x is t squared and y is 4t cubed minus 1 in the arc length from when t is 0 all the way to 1. So we're going to walk through the process again really quickly and then how to do this problem. The first thing is, since this is arc length, this is based on the distance formula, which you all know. We're going to change the distance formula around a little bit, so it looks like this. Notice that x2 minus x1 is actually the change in x. And from what you may remember is that since we're doing an arc length, we're going to do the sum of tiny little distances, which is how we bring the integral into the sum of tiny little distances. The difference is all these distances are going to be in terms of t. So what I need here is I need this to be in terms of t, so I need a dt. If that's the case, there's my dt, but I can't just put dt there unless I also put dt here, right? And we're going to keep showing you where we're going. Most of you can already predict probably where we'll end up. But that gets rewritten this way. Notice the dt here. And now it's under the radical. That's why it's dt squared. And it brings us to our arc length formula, which is the integral. Forgot something here. The integral from a to b of the square root of dx dt squared plus dy dt squared dt. If you recall, when we did it in terms of x, this said dx, and this was 1, which should make sense because it's dx dx, and dx dx is 1. So what I'm going to do is I'm going to take this, and we're going to bring it up here to see how we do our problem. Okay. So I'm going to use this formula now to finish up this process. We already know that it's going to be the integral from 0 to 1 of the square root of dx dt is 2t squared plus dy dt, which is 12t squared squared dt. And all we're going to worry about right now is the setup. So that is it. Have fun on your homework.